Copyright in these lectures is either owned by the ANU or a third party who has licensed the ANU to use it. Students may use the recording for personal study only. No lecture may be communicated online, copied or shared without the prior permission of the ANU.
All right, good morning, everyone. So let's quickly do two examples about binomial option pricing. Then if we have sufficient time left, we're going to finish off the option trading strategy from last week, right? So let me just first read out the question to you. So the question says, you have been researching the resource industry over past few weeks and are certain that the share price of companies within this industry will fall over the next 10 months. So as a result, you have decided to buy a put option on BHP. So the put option has a strike price of 35 and will expire in 10 months' time. So the current spot price of BHP is $30 per share. The volatility on BHP share price is 30% per annum. The risk-free rate is 5% per annum. And the bracket tells you that all interest rates are continuously compounded. All right, so it has two parts to this question. The first part says that assume the put option is European style, use the binomial option pricing model to find the value of this put option, and you can assume 2 time steps of 5 months each. Then the next question says, assume now it is American style put option, calculate the current value of this put option, right? So basically, the first part of the question says, assume it's European put option. The second part says, is American put option. All right, so in Monday's lecture, I simply gave you the proportional increase and decrease, right? So that's our little u and the little d here. Now, in fact, we can calculate the proportional increase and decrease by using this formula here. Basically, what this formula tells us is the proportional increase is actually a function of the volatility, right? So that's the share price volatility and also a function of the delta t. So that's the time horizon for each step in the tree. And then the little d, the proportional decrease, is simply 1 divided by the little u. So 1 over u will give you the proportional decrease. So we can actually calculate u and d. So what do we know? We know that volatility of the share price is 30%, and the delta t is 5 months, right? So that is expressed in a fraction of years, so it's 5 over 12, all right? So the u is equal to e to the power of 30% multiplied by the square root of 5 over 12, and we get the proportional increase is 1.21367. Then 1 divided by the little u give us the proportional decrease, the little d here, which is simply 0.8239469. Right? So once we have our u and d, the next step you should do, so that's the first step, as I indicated here. Then the second step you should do is to simply draw the tree. Right? Remember how we draw the tree? Going back to the question, so we were told the current spot price for BHP is $30, right? Then we start with $30 today, and then we take that $30, we multiply by the proportional increase, the little u. And we know what the u is. U is 1.213, right? So we take that 30, we multiply by 1.21367, and we get a share price up here, 36.41, right? And the way we get the share price down here is we simply take the $30 price, then we multiply by the D, which is the proportional decrease, and we calculate here, That's 30 multiplied by 0.8239. Then we get a share price down here is 24.72. So basically, you repeat the same process to get the remaining branches in the tree, right? So everybody is quite familiar with the procedure here. Now, once we get the entire tree, the next thing you should do is to quickly write down the option payoff, the put option payoff, at each terminal point. So we have 3 terminal points, right? So we have share price finish here, 44.19 cents. Do you remember what is the strike price? So going back to the question, we were told the strike price is 35, right? So if the share price go up, then go up again, finish at a price of 44.19 cents, shall we exercise this put option? If the share price increase, then increase again over the next 10 months, finish at a price 44.19, should we exercise our put option? Yes or no? The share price is above strike. What's the decision rule for put option? No, right? No, of course not. You should never exercise your put option if the final spot price is above the strike. All right? So obviously, we're not going to exercise this out-of-money put option, so the put option finish with a value of 0. So we quickly write down the payoff here, 0. Now then the share price can take 2 passes to reach this $30 terminal point. The share price can go up, then go down. Alternatively, the share price can go down, then go up again. Either way, it's going to end up with a price of 30. Right? So 30 is lower than our strike price, 35. So shall we exercise our put this time? Yes, we should, right? So we exercise our put, we make a payoff of $5. So we quickly write down the payoff is 5. Now, if the share price going down over the next 5 months, then going down again, right? So we end up with a really low share price, $20.37. So this time we have a deep in the money put. So our put option is deep in the money. If we exercise that deep in the money put, we're going to make a whopping payoff of 14.63 cents. So we write down the payoff here, right? So once we quickly work out all the payoff at a terminal point, the next step you should do is to calculate the risk-neutral probability. Right? So remember, what we have discussed on Monday is that once we step into this risk-neutral world, we can calculate a risk-neutral probability that will be consistent with risk-neutral investors' risk preference. If we can do that, then we can use the risk-free rate as the appropriate discounting rate to discount the expected payoff back to the present. Yes, that's what we discussed on Monday, right? Because in Monday we demonstrate that investors' actual risk preference does not affect the pricing of the option, right? Because we showed that even we try different probabilities, even we plug into the wrong probabilities, we can always get the correct option price. Because we demonstrate, it turns out the value of the option does not depend on the real probability. The value of the options simply depends on the underlying share price, right? So all the information we need is the share price and the share price volatility, because having the volatility helps us to determine the proportional increase and the decrease. And then we just need the risk-free rate. So having all of that information, we can work out the option price, yes? And we can discount that back to the present using the risk-free rate. Now, alternative way to think about the risk-neutral pricing is that price this option is actually riskless. Because in Monday, we demonstrate that if we can, long delta unit of shares and short the call option, we can create this riskless portfolio, the portfolio that has a payoff identical to a riskless zero coupon bond, right? So by using the delta hedging, we can remove all of the risk. If we are not exposed to any risk, we can discount the expected payoff back to the present using the risk-free rate. All right, so once we get that out of the way, let's calculate the risk-neutral probability. So that is the equation to calculate P star. the probability of going up. So we know what the risk-free rate is, 5%. Remember, the delta t here is the time horizon for each step. It is not time to maturity, all right? It is not the time to maturity. So that's 5% multiplied by 5/12, then minus the proportional decrease, the d, then divided by the difference between u and d. So we get a probability of going up is 50.55, right? So basically, it tells us there's 50.55% chance the share price can go up. Now, 1 minus the p star give us the probability the share price going down, which is 49.42. Okay? So that's your third step. Third step is to work out your risk-neutral probability. Now, as I mentioned in Monday, that because with the European option, we know the exact timing of the cash flow, right? With European option, you have no choice but to exercise the European option at the date of maturity, right? So all the cash flow happens at terminal points. Now, if we know the exact timing of the cash flow, we can effectively discount all the cash flow back to the present within one go, right? Because there's no uncertainty in terms of the decision to exercise. Now, if you understand that, so we can actually work out an expected payoff at this terminal point, then we discount all the way back 10 months. We're not going to discount back 5 months at each branch. No need. We simply discount all the way back 10 months. All right? So that is with European option. With the American put option, you cannot do that. All right, so the way we're going to work out the value is by utilizing so-called path probability, right? So what is the probability that we end up with the share price up here, 44.19? There's only one unique way that you can end up there, right? Which is for the $30 share price to go up, then go up again, you end up with 44.19 cents. How about the share price end up really, really low, $20.37? There's only one unique way that you can get a share price of $20.37, which is to take this current $30 price, going down, then going down again, right? So we get the share price down here. However, there are two ways we can get to the middle point, which is for the share price to go up, then go down. Alternatively, for the share price to go down, then go up again. Either way, we're going to end up with the share price of 30, right? And luckily, we know the probability of share price going up, so that is one unique way of ending up with the share price of 44.19. So that's simply the risk-neutral probability of share price going up square, right? Square represents is up times up, right? Now, if we do that, we're going to end up with the share price 44.19, and that's an out-of-money put option. We don't exercise that, right? So we simply leave that out-of-money put with a value of nothing. All right, and I mentioned before, we have two ways to get to the middle point, $30, which is for the share price to go up, so that's the probability of going up, 50.58. Then times the probability of going down, 49.42. So that's the up and down. Alternatively, we can get to the $30 points by going down, then going up, but the path probability is the same, right? So what we can do is we can 2 multiplied by that path probability represents that is going to happen twice. And if we end up with the share price of 30 is $5 below the strike, right? So if we exercise the put, we make a payoff of $5, so that multiplied by the $5 payoff, and then there's only one unique way that the share price can go down to $20.37, which is to go down, then go down again. That is 49.42 probability square, right? Square represents that's 2 consecutive downturn, and that would lead to a whopping payoff of 14.63. So that is the expected payoff of this put option in the terminal points at the maturity date. Then we can discount this payoff all the way back 10 months. So I use the red to highlight. This time, we're discounting 10 months over 12 months, right? We discount all the way back 10 months at a risk-free rate, right? Because we now step into this risk-neutral world, so we can use the risk-free rate to discount it. So the risk-free rate is 5%. Now, if we do that, we discount that back all the way 10 months, we get a European put option is priced at $5.82. $5.82. Now, in the exam situation, don't waste your time to write up this component here, because effectively that's just a zero, right? Multiplied by an out of money put, the payoff is nothing, then that entire component is zero. So don't bother to write it in the exam situation. That saves you a bit of time. So any question with the European put option? All right, if not, then the second part of the question says, assume it is now American-style put option. Calculate the current value of the put option. So as I mentioned in Monday, with American put option, it's perfectly fine for you to exercise American put early, right? It is perfectly fine for you to exercise American put early. Well, if that's the case, then we don't know the exact timing of the cash flow. So we have no choice but to work tediously from the right to the left at each branch of the tree. There are two steps. The first step, same as before, you calculate the expected payoff from the option, you discount back 5 months. But before you're writing down the discounted value, one additional step. You should check how much is the intrinsic value of the put option, right? Checking the intrinsic value is the strike price minus the share price. Basically, that tells you what is the value of exercising the put option immediately at this moment. Basically, we are comparing exercising the put immediately versus holding on to the put option for a bit longer time, for another 5 months. Now, if the value of exercising that is higher than holding on to the put option, we should exercise the put immediately. So we should write down the intrinsic value at each node. If the intrinsic value is lower than the discounted value, that indicates we should hold on to that put option for a bit longer time. Because if you're holding on to that put option, that option has a higher value because there are more chance the share price might become in the money, right? So the put option might become in the money and that provide additional value. We should hold on to that put option. So just remember that, one extra little step. So again, the same old tree, the tree we just draw. And as I mentioned, there's no other way but to tediously work from the right to the left. We've done this calculation before. We know what the U and the D is. And we also know the risk-neutral probability exactly as we calculated before. All right, so this time let's start from the upper right branch, all right? Upper right branch. In other words, we are standing in this point, not B, all right? We're standing here and we're thinking 5 months ahead. We're thinking, what is the expected payoff of the put option? Well, we know the probability of going up, right? So there's 50.58% chance go up. If you go up to 44.19 cents, it has a value of nothing. And there is 49.42% chance the share price go down. If it finish at a price of 30, that provide a payoff of $5. So let's do that. So that's the probability of going up, finish with a value of nothing. That's the probability of going down and provide us payoff of $5. Because I'm standing at node B thinking 5 months ahead. So we should discount this expect payoff back 5 months in node B, right? So that's what I did. I discounted back 5 months, so 5 over 12 using the risk-free rate. So once I do that, I get a discounted value, $2.42. Again, because it has a payoff of nothing, so to save a bit of time, you don't need to write it out in an exam situation, so I crossed it out. And before we write down this $2.42 in node B, one thing we should do is to check whether or not we should exercise this put early, right? Whether we should just exercise this put at not B instead of holding on to the put. How can we check for that? Now we know the share price in not B is 36.41, right? And that's higher than the strike price, higher than the strike price 35. If it's higher than 35, that means exercising the put will lead to a loss, right? So we simply don't exercise the put early, right? So we compare the intrinsic value with the discounted value, and which means holding on to that put option for another 5 months, there are more opportunity for this put option to be in the money. So that's worth something, and that's worth $2.42. So we simply write down $2.42 at not B, all right? Then we're going to repeat the same process for the lower half branch, okay? So lower right branch here. Now again, we're standing in not C, and we're thinking 5 months ahead, right? So we know the probability of going up, 50.58 going up, and we have payoff of $5. There's 49.42% chance the share price could go down. If it go down, we have a big payoff, 14.63, right? We know the probability of that happening, and we work out that is you expect the payoff. And because we're standing here and thinking 5 months ahead, so we should discount back 5 months in not C. So we discount back 5 months using the risk-free rate 5%, we get a discounted payoff of $9.56, right? $9.56. But before we write down $9.56 in not C, we should ask ourselves, shall we exercise that put option just in that point in time at not C? Now, the share price in not C is 24.72. So 24.72 is lower than our strike price. If you exercise that, we can make an immediate payoff of $10.28. So $10.28 is higher than the discounted value, which means exercising the put option now has a higher value compared to holding on to that put option for another 5 months. So the rational decision is to exercise the put option now and to get that $10.28. So that's what we're going to do. We exercise that now, and we get $10.28. So we should write down $10.28 at not C. Right? We don't write down the discounted value. Instead, we're going to write down the intrinsic value. That's the value of exercising that put option immediately. All right, so we write down $10.28 in not C. Then the final one last step is to actually discount back to the not A. Right, so we know the probability of going up. If you go up, we have a value of $2.42. That's the value we discounted back, right? And if the share price go down, then our put option has a value of $10.28. $10.28 represents exercising a put in not C immediately, all right? So that is the expected payoff from this put option, and we're going to discount back 5 months to the present to get our put option price. So we discount that with the risk-free rate. Back 5 months, we get in the put option price $6.17, right? And bear in mind, if this put option is European style, it's valued at $5.82. Now, if it's American put option with the same option written on the same underlying stock price, it costs us $6.17 to get into, which makes sense. So, because the American put option is always worth more than its European counterpart. The reason is because you have the additional flexibility to exercise that put option early, and that's worth, extra bit of money. So that's why the American put option is selling more than its European counterpart. Does it make sense? Does it make sense? So any question with the first example here? Okay, if not, let's have a look at the second example, which is a three-step tree. So far we've done one step, we've done two steps. Let's do a three-step tree. So the process is identical. It just is more tedious, okay? So it says the stock price is currently priced at $100. In any given 3 months period, the share price would either go up by 13.31 or it would go down by 11.75. And we were told risk-free rate is 5% continuously compounded. Again, we have a put option written on the stock with a strike price of 110 and has 9 months to expiry. So the key information is here. The time to expiry is 9 months, and the question says in a given 3 months period. So in other words, we're going to split 9 months into three 3-month periods, which means we have 3-step tree here. All right? Again, the question says, first assume this option is European style, then the part B says assume this option is American style, and calculate the price for those. Okay, so we first step always to find the little u and the little d, the proportional increase and the proportional decrease, because only have that information you can draw the tree, right? So the entire tree is based on the u and d. This time the u and the d is simply given to us, so we quickly work out the u and the d, and then the next step is to draw the tree, right? So the way we're going to draw this tree, sorry, I cannot remember all the prices, so I need to have a look. Yeah, so the way we're going to draw this tree is to take the current share price, $100, then multiply by the little u, the proportional increase, 1.1331. Then we get a share price up here, right? So that's simply $100 multiplied by the u here. We get a share price up here. Then the way we get this 88.25 is by taking this $100, then multiply by the proportional decrease, the little d, which is 0.8825. Then we get a share price of 88.25 down here. Then the remaining task is simply finish this tree, right, to repeat this whole process. And this time we have 4 terminal points instead of 3. So we have the share price finish up here, 145, a share price finish here, 113, and the share price finish down here, 88.25, and down here, 68.73. So same process as before. We need to work out the payoff at each terminal point. So remember, our strike price is 110, right? So when share price finish up here, 145, shall we exercise this put? If the share price finish up here, 145, shall we exercise this put? No, we shouldn't, right? And same decision goes to here. If the share price finish at 113, we should not exercise the put, right? So this is out of money put with value of nothing. If the share price finish here, 88.25, that is lower than our strike, 110. We should exercise our put and make a payoff of 21.75, right? And when the share price takes 3 consecutive downturns, going down, then going down again, we get a share price of 68.73. So we should exercise our put and make a payoff of 41.27. Right? So everybody understand the steps. It's quite mechanical, right? Then the third step is always to calculate the risk-neutral probability. So we know the risk-free rate is 5%, and each step, remember the delta t is the time horizon for each step, is 3 months, 3 over 12, then minus d divided by the difference between u and d. So we have the probability of the share price going up, 51.91. And 1 minus that, is the probability for the share price to go down, 48.09% chance to going down. All right, so once we have the risk-neutral probability, then the first question says, assume it's European style, right? What we can do is we can, again, similar to the two-step tree, we can work out the expected payoff at terminal point. Then we discount all the way back 9 months. So we can get the European put option price within one go. Okay? And we know the past probability of each payoff. So that is 3 consecutive upturn. We get a share price here. It finished out the money. And there are 3 ways we can get to this point. But get to this point has a payoff of nothing, right? So what we need to figure out is the past probability of getting to the share price of 88.25. So let's analyze that. The share price can go up, then can take 2 consecutive downturn, and we'll get to that share price. Alternatively, the share price can go down, then go up, then go down again. And the third way we can get to this share price is for the share price to take 2 consecutive downturn, then go up again, right? So we'll get to this 88.25. And so as I mentioned before, you don't have to write out the 0 payoff. So 3 consecutive upturn will get us a payoff of nothing. So we don't write that out. And if you get to this point, 113 also has a nothing payoff. So don't bother to write that either. Now, as I mentioned before, there are 3 ways we can get to the 88.25 share price, right? So that's 3 multiplied by that past probability. Okay? That means there's 3 ways we can get to the 88.25 share price. And if we get to that point, we're going to get a payoff of 21.75. And again, there's only one way we can get to the 68.73 point, which is for the share price to take 3 consecutive downturn, right? So that's simply this probability, the probability of going down to the power of 3, represents 3 consecutive downturn, and we have a whopping payoff of 41.27. So if we do that and we work out the expected payoff is $12.42. And because it's European option, we can discount it all the way back 9 months, right? At a risk-free rate 5%, we get this European put option valued at 11.97. So there's not much difference between the 2-step tree and 3-step tree. So steps behind those are exactly the same, right? It's just more tedious. Okay, so the second part says, assume this put option is American style, and how are we going to value that? Again, we're going to work from the right to the left at each branch. And first, we're going to work out the discounted value of the payoff. Then we're going to work out the intrinsic value. Then we're going to choose the higher value out of the 2. And we're going to write at each node. Okay, because if the share price finish at 145 or the share price finish at 113, both give us a payoff of nothing. So we can pretty much skip this branch here, because if you discount that, that would give you a value of nothing. And also, with the share price of 128, is also below the strike price 110. So either way, we know the value here is nothing. So we don't bother to start with this branch here. So what we're going to do is just to start with the branch at this point, right in the middle. All right? So we're standing here in node 1, and we're thinking 3 months ahead. We know the probability for the share price to go up. If it go up to 113, this put option has a value of nothing. Now, for the share price to go down to 88.25, it has a payoff of 21.75. So that's the probability of that happening. And then we're going to discount back 3 months, right? Because we split 9 months into 3-month step. And we discount back using the risk-free rate. We get the discounted, the payoff is $10.33. So before we write down $10.33 in Note 1, let's check the intrinsic value. So the share price in Note 1 is $100. So our strike price is $110. That's $10 below the strike. If we exercise the put, immediately give us a value of 10. However, holding on to that put option for another 3 months give us a payoff of $10.33. In other words, we should wait a bit longer, right? So we should not exercise this put in Note 1. We should wait longer to get the higher value, $10.33. So that's what we did. We write down $10.33 here. Then we work on this branch. We know the probability of going up and going down. We know the payoff of those outcomes, right? So that's the probability going up. If we go up, we have a payoff of 21.75. If the share price go down, we have a big payoff of 41.27. So that is your expected payoff. And you discount back 3 months, discount back from here to here, 3 months. And we have a discounted value of $30.75. Again, let's check the intrinsic value. Let's check what is the value we get if we exercise the puts immediately in Note 2. So Note 2 has a share price of 77.88. So 77.88 is 32.12 below the strike, right? So if we exercise the put, we get that much payoff. And 32 is higher than 30. In other words, we should exercise the put immediately to get that payoff instead of holding on to that put option for another 3 months. So that's what we did. We write down the 32.12 in this branch here. Again, we're going to repeat the same thing for this branch. If the share price go up, we have a payoff of nothing here, right? Because the payoff are both 0 in the terminal points for this branch, and this point has a payoff of nothing. Now, if the share price go down, we have a payoff of $10.33. That's the value we discounted back from the terminal point. And we discounted back 3 months. We get the discounted value is $4.91. Again, we need to check whether this put option is in the money in Note 3. So that's above. So if the share price finish at 113, that's above the strike. So exercising the put will lead to a loss. So we don't exercise the put. We write down the discounted value. So we choose to wait a bit longer. So I wrote down $4.91. Then the same thing goes to this branch. We know the probability of going up. So go up, we have a value of $10.33. If the share price go down, we have a payoff of 32.12. Right? So the way we get this 32.12 is to exercise the put immediately in this point. So we discount back 3 months, and we get discounted value is $20.55. Again, we need to check the intrinsic value. So the share price, with the share price of 88.25, we have an intrinsic value of 21.75. So that is higher than the discounted value. Again, we're going to choose the higher value here, which is to exercise the put immediately in that point. So we write down the intrinsic value instead of the discounted value. And then the last step is simply discount everything back to the present. All right? So that is the expected payoff, and we discount back another 3 months. We get a discounted value 12.85. And intrinsic value at present is $100. It's $10, right? So that's $100 compared to the strike price, $110. So that's $10 that's $10 below the strike, so it has intrinsic value of 10. Of course, holding on to that put option a bit longer has higher value, $12.85. So if this put option is American style, it's selling for $12.85. If this put option is European style, it's only selling for $11.97. Again, we proved that the American put option is always a bit more expensive than its European counterpart. All right, so I was planning to reserve a bit of time to go through the option trading strategy, but we only have 10 minutes left. So let me try to finish the trading strategy next week. Okay, so next week we're going to talk about Black-Scholes option pricing model. And any questions for today's workshop? I think it's quite straightforward, right? Binomial option pricing. Any questions? All right, if not, that's all. Thank you, everyone. So let's talk outside. Yeah, let's discuss outside of the lecture series.